So we're about to try to add two fractions together. But the thing is, they don't have the same denominator. And it's different from when you're multiplying, because when you're multiplying, it doesn't matter what the denominator is, and it doesn't matter what the numerator is. You're just going to multiply the two numerators and the two denominators. But when you are adding, you must have the same denominator and the same, well, not the same numerator. You must have the same denominator. So we have to have what we call a common denominator. And in this case, the common denominator is whatever the lowest common multiple is for this fraction. And that lowest common multiple is what, in this case? For 2 over 3 plus 1 over 6. What's that lowest common multiple? Yes. No, because it has to be as big as or bigger than the denominator that's there now. So no, you're right, it is actually 6. It's actually 6. It can never be smaller than any of these. And sometimes when you're stuck, the best thing to do is just multiply the two of them. But you don't really need to in a case like this, because there is a multiple which is lower than that, which would be 6. So I'm going to put 6 in. Then I'm going to ask the question, what do I multiply this 3 by to get 6? The answer is 2. So I have to multiply the top of that by 2. So 2 times 2, there's a plus there. What do I multiply 6 by to get 6? The answer is 1. So it's 1 times 1, which is just 1. So this answer works out to be 4 plus 1 over 6, or just simply 5 over 6. That's easy enough, hopefully. The one that's below it is asking us to minus a negative. Well, you all know when you, and by the way, this fraction here is a negative fraction because it has a negative numerator but a positive denominator. So treat the whole thing as a negative. And if I'm minusing a negative, we all know it means we have to add. So treat this as being 3 over 8 plus 5 over 6. Right? Minus a negative, you're adding. Okay. So the question now is, what is this common denominator? What is this number that is a multiple of 8 and 6, the smallest possible one that you can have? Yes, Jay. That would be it. Thank you. All right? Triage is probably going to tell me the same thing. It is, in fact, 24. Again, if you're stuck and you can't figure out the lowest common multiple, you just multiply the two numbers together. It will mean that at the end, you'll have a number that's probably too big and you're going to have to reduce it down. But in this case, it's not so hard. It's 24, as Che just said. So I put a big long 24 or a big 24 under the one long line. Then I ask, what do I multiply 8 by to get 24? The answer is 3. So it's 3 times 3. What do I multiply? And then there's a plus. What do I multiply 6 by to get 24? It's 4. So it's 4 times 5. So it works out to be 9 plus 20 over 24. Or 29 over 24. Now, the truth is that any typical calculator, yes?
Why did you multiply it by the 3 and 5?
Good. So here's how this works. Just remember to take out the earbuds for me, please. Yes? Oh, help yourself. Yeah, just help yourself if you need tissue, okay? Here's how this works. You're trying to make this fraction, this 3 over 8, have a denominator of 24. Right? The denominator right now is 8. But if you want to make it a denominator of 24, you have to ask, what did I do with the 8 to make it into 24? Well, I multiply by 3. So if I multiply by 3 to make the bottom into 24, I have to multiply the top by 3 to make that 3 times bigger for the fraction to be the same fraction. So we multiplied 3 times what was there before, which is the 3. I asked the same question. What do I multiply that 6 by to get 24? The answer is 4. So I have to multiply the top of that fraction by 4 to make it so it's the same fraction. Okay? And thanks for that question. Really appreciate those questions. Then when they're the same denominator, I can add the two numerators and I have my answer. Well, that's just fractions. And by the way, I don't need you to make this into a mixed fraction. Leave it as 29 over 24. Even my calculator that I let you use will do that for you and give you an improper fraction. Don't need it to be anything more than that. Well, let's start working our way through what happens when we have not regular numbers, but rational expressions, meaning it has x's in it. These are not just numbers anymore, but it also has variables like x or y or whatever other variable. Okay, the principle is the same. We need a common denominator. Fortunately for us, the first three questions already have a common denominator. So what does that mean? Just add the two numerators. So in the case of the first one, we're going to say, okay, since they both have a denominator of 7, I don't have to do anything to the two tops. It's going to be simply x plus 3x. And that means that I'm talking about 4x over 7. As easy as that. That's done. Are there any restrictions though? Because we always have to ask that question. If you look at this, do you see any possibility of you having something which is undefined? Because that's where your restrictions come from, right? Is anything, you and this bag, right? Is anything going to make this become 0? Can you see any number that x could have which could cause a problem? Anybody? Nobody sees any issues there? Yes. Okay, let's see what happens with 0. If x was 0, I'd have 0 over 7. Okay, well, that's just 0. That's fine. 3 times 0 is 0. That will be 0 over 7. That's just 0. It's when 0 is in the denominator that we have an issue. In the numerator, we don't care, right? Because 0 can be divided by anything. We're going to get 0 at the end. Okay, yeah. Yeah. So that's the deal right there. Right? There are no restrictions on in a case like this. Listen carefully over here. All right, that's good. That's good. Second question, same thing. Right? I have a common denominator from the start. And that denominator is p. So I'm going to say, okay, I don't have to multiply the top by anything because the denominator is already p. So it's just going to be 2 minus 5t. That's all it is. That can't be reduced. I can't put any like terms together here. So that question is done. Okay? I can't do anything with that, but we still have to ask the question. Are there any restrictions? Because we still have to always state that if there are any. I see hands going up. Aaron, what do you want to tell us? Exactly. Exactly. So now this time the difference, Priyash, is that this time the denominator has a variable in it. And that variable could have too many value. And so if you make it into 0, now you got a problem. Okay? All right. Let's keep going. So far, they all have the same denominator. That makes it easier for us. So this one is equal to 5 on the bottom again. Then I have the 2a plus 3 plus the 5a minus 4, which means that I can simplify this to give me the two, just put your like terms together. Yes. Let me repeat that for the recording and give you full credit for that. Abel said, yeah, you just put that p was 0. That's not right. No, p cannot be equal to 0 is really what we're saying. Right? That's what Abel is pointing out. It should not be a p is equal to 0. P is equal to 0, we have a problem. So p is not equal to 0 is really what we should be saying. Okay, so thank you for that. All right, and then we just put our like terms together now. So 2a plus 5a, of course, is 7a. 3 minus 4 is minus 1 over 5. Restrictions. What are the restrictions in this case? Tell me, talk to me. What are the restrictions? Yes. No restrictions. Thank you very much. No restrictions. Right? Focus on the denominator if you're looking for restrictions. If there's nothing in the denominator that could change to 0, there are no restrictions. The denominator is 5. 5 is not about to change into anything else. 5 says, I'm 5. Deal with it. I'm not going to become 0 for anybody. X's are more flexible. P's are more flexible. Variables are more flexible. They're willing to change their value depending on what you want to assign to it. But constants say, look, Leave me alone. I'm going to be this number forevermore. So we can't change that to a 0. Okay, so that's a nice, easy start for us. Let me delete this page. All right, so let's say we are subtracting now, as in the case of this one. Let's say we're subtracting. There's a little bit of a danger that sometimes students get caught by. I don't want you to get caught by that. So, I see people squinting in the back there. Let me try to make this a little bit bigger for you. Here's the thing that you have to be careful about. Yes, they have a common denominator of 3n, so we can start with that. And yes, I don't have to multiply the top by anything. So it's 4m minus 2. But you see that minus sign there? That minus sign is sometimes a little deceptive because I'm not just minusing the 7m, I'm minusing everything on top. Everything on top is being subtracted, which means that what I should have is this, minus 7m and minus 9. If that had been a minus 9, it would have become a plus 9 because I'm minusing a minus. But in this case, I'm minusing something which was positive. So the two of them, in a sense, get multiplied by minus 1. Does that confuse you? Is that something that, what do you think? Does that make sense to you? Okay. Both have to be minus. And the mistake a lot of students make, and I don't mean you, all right, not talking about people in this class, or I hope so, is that they only minus the 7m and then they add the 9. No. You're minusing both. Yes. AJ. Say it again. Yes, I'm minusing the 9 as well. Why? Because the minus applies to the whole numerator. Everything on top is being minused. So I'm minusing both the 7m and I'm also minusing the 9. Yes. Then it would have become 7m plus 9 because you're going to minus a minus, which makes it become a plus. That's a great question. But of course, we should simplify this for what can be simplified. So 4m minus 7m is minus 3m. 3, that's m on top, right? Yeah. 3, oh, that's a terrible looking m. Hold on. Somebody's going to complain about that in a little while. That's more like an m. So that's minus 3m. And then minus 2 minus 9 is minus 11. That's all over 3n. I'm trying to make my n's look more like n's and not m's. Okay. Now, two things we have to answer. One is restrictions. Do we have any restrictions? Yes, Jay. Of course not. N cannot be equal to 0. Put that on the side here. And I'm making sure to put not equal to this time because, you know, we were warned. Abel was there to kind of make sure we didn't make that mistake. That's a 0, not a 6, by the way. The second thing is, can I reduce this? I see a 3 in the denominator, and I see a 3 in the numerator, and I'm thinking, I should be able to just... That's interesting. Rosie is shaking her head over here and saying, no, you can't do that. And she's right, you can't do that. Don't even think about it. Don't even get tempted to do that. Do you know why I can't do that? Can anybody give me a sort of a good answer for that? Yes. Because what, sorry? True. That's true. I was looking for something a little different, though, as to why we can't just reduce it. Yes, Gar, what are you going to say? It's part of a difference. Right. That 3 is part of a difference. If this was, let me tell you, if this was, let me show you something. If this had been this, then we could have divided it out. But that's not what it is. Okay, so we cannot, please don't do that. Right? I'm pleading with you not to do that. Don't look at those two things and say, oh, there's a 3 and a 3, and I can just, no, you can't do that. Okay, let's get to the next question. We put our restrictions, we put our answer, and we're going to move on. Next question. For the first time, we don't have a common denominator. Right? The denominator is 3 in one case and 5 in the other. So what do you think we need to do if they don't have the same denominator? What do you think we're going to have to, how do we fix that is the question. Yes, yes. Absolutely. That's what we're going to do. We're about to find what that common denominator is. Can you recommend a common denominator? Yes. I think that's a good idea. So I'm going to put one nice long line with a 15 under it. And we're going to go through the process just as if it was regular numbers. Right? Just as if this was, a fraction with just numbers and no variables. What do I multiply 3 by to get that 15 answer, of course, is we're going to multiply that 5 by the 2 at the top. It's a plus. Let's put the plus in. What do I multiply this 5 by, this 5 by to get the 15? Yes. Sorry, what's that, Sharmeen? By 3, right? No, I thought I said Charmaine, right? Yes, by 3. So we're going to multiply the top by 3. So it's 3 times 4a. So we just have to multiply this out now. So that's 10a plus 12a over 15. So are we done now? Is that the end of the story? What do you think, folks? Any more? AJ? There's a common like term. So 10 plus 12 is 22. So it's 22a over 15. Now, when you get to that last point, you should always look to see, can I reduce this anymore? Truth is, in this case, you can't. There is no common factor at the top and the bottom, so you can't reduce it anymore. So you're done. Restrictions. Time for restrictions. Who thinks they can see restrictions? Yes. There's no restrictions. The denominator is a number. It's not a variable. So there are no restrictions there. Okay, last one. Help me out with a common denominator. You saw what we did the last time, right? I asked, do I need a common denominator? I heard yes, and I got what a common denominator was. And Aaron says what? 20 works. Thank you very much. 20 works really well. So why do we use 20? Because that's the lowest common multiple. Let's go through the process. What do I multiply 4 by? That gives me 20. The answer, of course, is yes, is 5. So let's take 5 times the k minus 7 minus, put the minus in, because we have to be careful with that. What do I multiply 10 by? That gives me 20. The answer is 2. Why am I holding up one finger? Sorry. 2 minus 2 times k plus 2. I notice that I'm multiplying by a minus 2. So that minus 2 is going to have to distribute inside of that bracket. Right? That's the thing I was talking about before. Right? You're really minusing the stuff in the second fraction. Okay, what do you think I'm going to do next? What do you suspect I'm going to do next? Go ahead, please, Vanna Hill. Of course you are. Of course we are. So that is equal to 5k minus 35. It's a minus 2, so it's minus 2k minus 4. All over 20. 5k minus 35 minus 2k minus 4. So we need to do some tidying up now. Correct, Emily? Okay, can you help me to tidy this up? Can you help me to put all my like terms together? You're going to ask somebody else to help us out with the restrictions. Go ahead, please. Is what, sorry? 3k, good. Good. And I noticed that you didn't pull a calculator out, and that's good. And that's all over 20, right? Now, the truth is the top can be factored. It's not a bad idea to do that sometimes, but it's not going to help you in this case because after you factor out that 3, you still can't reduce anymore, so you can leave it as it is. Not necessary in this case. Restrictions. Let me see if you can help me out with some restrictions, Jasmita. Any restriction? Sorry, Jasmita is and Krisha. Sorry, I meant Krisha. Krisha, can you help me out with any restrictions here, please? There are no restrictions. Focus on the denominator. When I ask the question about restrictions, look at the denominator. It was always just a whole number. No restrictions. All right, gets a little tougher now. Gets a little tougher. Look at that denominator, those denominators. They get a little bit more challenging as we go along. So 9t squared and 6t are the two denominators. Let's focus in, okay, this time it is going to be Jasmita. Let's focus in on the two numbers first, right? The two coefficients. It's 9 and 6. Give me what you consider to be the lowest common multiple between those two numbers. We'll get to the variables later on. 54 would work, but that's a big number. And I can think of a number that's smaller than 54 that both 9 and 6 can go into. And that's what I like to use. So we could use 54, but that's overkill. We don't need to go as high as 54. Let's give her a chance. Thanks for offering. Right? What do you think? Think of numbers, think of multiples of 9, think of multiples of 6, and try to get the multiple which is the smallest multiple between those two numbers. $30, well, the thing is 9 doesn't go into 30. Say again? Yeah, but you're going the other way. You know, you're thinking of factors of 9 and factors of 6. I'm looking for multiples. So multiples means numbers that can be divided by those two numbers. So that's what a multiple is, okay? So not you can divide it by the number because that's what a factor is. But when you multiply that by something, you get this multiple. So you're better off with the 54, but it's just too big. It's just too big. You had your hand up as well. What are you thinking? You heard that? That works, right? Because I can divide 18 by 9. I can divide 18 by 6. Make sense? So we're going to use 18. 54 is fine if we are desperate, but let's just go with 18. Okay? All right. So the suggestion we have is that part of this common denominator is going to be 18. That's the numerical part. Now let's talk about the variable part. We have two variables. One is t squared and one is t. They look similar. They're both t, but one is squared. You have a question?
Would it just be t to the power of 3?
Interesting. What were you going to say? Okay, so you're thinking t cubed and you're thinking t squared. Let me hear some other ideas. Yes. Interesting. And can I get your thoughts on that as well? Add up the exponents, I mean, so that you'd get t3 in other words? Interesting. Yes. Good. I like a lot of those ideas, and I like to hear the reasoning behind it as well. Here's how I normally teach this. If the variable is the same letter, in this case t, then sometimes you even have more than one denominator to work with. And I always say, look for the highest denominator, highest exponent, and go with that. The highest exponent here is t squared. You'll see in a minute why this works. So I'm going to go with the t squared. If there was a t cubed, if there was a t to the power of 5, I would have gone with that. But the highest exponent of all of these t's is t squared. So I'm going to go with 18t squared, and you'll see why that works when I write that down. I could have used TQ, but it's not necessary because that's not the lowest common multiple, is what we're saying, right? And I think some people are thinking, why don't you multiply the two things together? Not really necessary, because here's how this is going to work now. I can divide 18t squared by 9t squared. Think about that, right? There's something I can multiply this by that gives me that. And what is that, by the way? Yes, 2. Let's multiply 2 by the 5 then. Plus, what do I multiply? Yes, Angeli. So this one here by just 3? 3t, good. Because we're going to ask the question again. What do I multiply 6t by to get 18t squared? The answer is 3t. Exactly what Angeli just said. So I'm going to multiply 3t by the 1. Of course, that's still going to be 3t. So we're going to end up with the following. 10 plus 3t over 18t squared. That's what we're going to end up with. That doesn't look like a 0. It looks like a 6, so let me make it look more like a 0. So the question is, can we do anything else with this? Can anybody see another step that could work? Let me hear from Gary first. Gary, go. Oh yeah, because remember, there's a word in mathematics called commutative. Has anybody heard that term before, the commutative principle? Commutative law says that, and it works for addition and multiplication, is that when you're adding numbers together, the order in which you add them doesn't matter. What's 10 plus 6? 16. What's 6 plus 10? It's also 16. If I had even a bunch of numbers, like 10 numbers, and added them up, it didn't really matter what order I added them in. So they say that addition is commutative. Order doesn't matter. It works for multiplication as well. 10 times 5 is 50. 5 times 10 is also 50. What it doesn't work for is division and subtraction. So neither of those is commutative. So the order doesn't matter. So yes, I could put 3t plus 10. And I know why you're comfortable with that, because most times we put the higher exponents first, put it in descending order. So if you're a purist in mathematics, then you would say, you know what? I really prefer to see it look this way. I'm not that much of a purist, to be honest with you. But I know you have to put it in all the like terms together. But yes, some people would say you really should put the 3t plus 10 first over the 18t squared. But I still have to answer the question, 2 questions. Can I do more with this? You had your hand up, yes. You could factor out the 3t, but 3 doesn't go into 10 though, that's the thing. 3 doesn't go into 10. So I can't factor out 3 out of this, because 10 is not divisible by 3. If this was 9, I would agree with you, but it doesn't go into 10. Okay, but good thought anyway. Yes, Che. No, you can't do anything with that, and that's the thing I don't want you to do. Don't want you to think of that 3 and that 18. You can't do that. It's part of a sum. Okay. Yes, you had your hand up as well. Yeah. No, you can't do that. You can't do that. But restrictions. Let's go there. Let's go there. And Gary says there are restrictions. What are the restrictions? That's exactly right. T cannot be equal to 0. Focus on your denominator. What's going on with your denominator? Because that's where the action is when you're looking for your restrictions. All right. It gets more interesting when you're looking at binomial denominators. And far more work, by the way. I just should say that. You can read all of that later on. I just want to get into it because, we don't have so much time that we have to be reading everything. We should just sort of learn by doing it. All right? So you ready for this? Yeah. Okay, so Chair says he's ready. The common denominator here is the easy one, first of all, right? Because it's already the same denominator. So that's fine. We just have to simply use that common denominator, m plus 3, and then just put the 3m minus 5 plus, because it's plus, you don't have to worry about these both being negative, plus the m plus the m plus 4. Why is it doing that? Plus the m plus 4. That's all. Keep the same denominator, m plus 3. Put, because you're going to ask, what do I multiply m plus 3 by to get m plus 3? It's just 1. So it's just 1 times the top. So it remains 3m minus 5. What do I multiply that by to get that? It's just 1. So it's just 1 times m plus 4. So there's no need to really sweat this one. All right? This is just a standard, put your two numerators together because your denominator is already the same. So let's just simplify now. 3m plus m is 4m. Minus 5 plus 4 is minus 1 over m plus 3. But I'm going to tell you right now, there is a restriction. I'm not even going to ask if there is one. I'm going to say there is one. There is a restriction. Let me see what Jahim thinks. Thank you very much. Well done. And I saw all the other hands that went up, and I'm sure they were going to tell me the same thing. M is not equal to minus 3 is the answer, because putting minus 3 into this makes this become 0. We don't want that. We can't have that. Okay. So there's your first fairly simple example with this restriction, and we're done. Don't get tempted to do anything else with that, but there's nothing else you can do with that. There's no common factor. None of that. Move on. I can't tell. I'm so disappointed and distressed sometimes when a student gets the right answer and then gets a little carried away and goes on to do something else which makes it the final answer wrong. You had the right answer there, but you thought you could do more with it. You can't do anything with that. Move on. You know, there's a saying, quit when you're ahead. All right. Uh-oh. This one is a minus. What's our common denominator here? What's our common denominator? Can somebody help me with that? Yes, AJ. The n plus n minus 2 is already a common denominator. Again, don't have to sweat this one. So it's over n minus 2. But be careful, that minus sign, put the phone down for me, please. You'll get your chance with your phone later. That minus sign is a bit of a trip, something to trip you up if you're not being careful. The 5n minus 7 is fine. But we're going to do what now? Yes. Let's see. Some hands are going up here. Yeah, go ahead, please. Abel. So it's minus 2n? Correct. Correct, because you're minusing the two things on top. Well done. So it has to be treated as if you are minusing everything that's on the numerator. In this case, one of them was already a minus, it becomes a plus. And then we have to just go ahead now and put our like terms together. So that would be, what is that? 3n, and that would be minus 4 over n minus 2. All right, very quickly. Restrictions. Go. Of course. Of course. Thank you, Amira. Aria, sorry. N cannot be equal to 2. Everybody clear on the restrictions now? Yes. All right, go ahead. Don't forget to sign out on the way out, please. All right, let's see if we can fly through the rest of these now. They do get a little bit more interesting as we go along. Look at that. And let's see if you can tell me what you think would be the, because this one doesn't have a common denominator right away. It does not. It does not. So, can somebody recommend to me what they think a good common denominator might be in a case like this? Akifo, talk to me. The two things just multiplied? No, say it again. Oh, go on, say it again.
I was gonna say you can make the two a fold.
Like you mean foil them out, like multiply them out? I prefer to keep them multiplied without foiling them out. Yes, 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 yes. The x, you see, you mean the x minus 4 times the x plus 2 is what you said. Absolutely. That is the common denominator. That absolutely is the common denominator. Sorry, x minus 4. That absolutely is a common. So one of the things we said is that if you're stuck with getting a common denominator, multiply the two denominators, right? And that's exactly what we just did. All right. So my question now for Ashton is, all right, so we did that. What do we multiply this denominator by to get this denominator? Because we have to multiply the top of that by that, right? So what do we multiply this by to get all of that? Okay. This is the original denominator of x plus 2, correct? What did I multiply? I'll ask the question a different way. Divide this denominator by that denominator. What do you get? Yes. Divide this by that. What do you get? Yes. Yes. Correct. So because here's what you're really doing. You're multiplying this by x minus 4 to get all of this. Is that really what you're doing? So if I multiply this by x, the top has to multiply by x minus 4 as well. So on my next line, I'm going to multiply x minus 4 by the x minus 2. Right? Does that make sense? Please, yes. Does that make sense to everybody? Plus, we're going to ask the same question again. What do I multiply the x minus 4 by that gives me all of this? Yes, the x plus 2. So I'm going to multiply x plus 2 by the x plus 1. And as scary as that looks, to what we've got there, that is what we need to do. Okay. Abdullah, what do you think happens next? What do you think we have to do with this monster? Yes, that's exactly right. That's what you're going to do for us now. So let's foil out the top of this. So I'll put some lines in here for you, if that helps you out. That times that times this, and then this times this, that times that. Go. Yeah. Negative 2x, you said? Good. Keep going. Negative 4x plus 8. Guess what? We have to do the same thing again. Yes, sir. Yeah, that's why you got to, again. We had to ask what was the common denominator, which we decided was the product of the two denominators that were there before. The x plus 2 and the x minus 4. And then we asked, okay, so what do you multiply this x plus 2 by to get all of this? The answer was x minus 4. So we multiply x minus 4 by the top of that. That's what this is. Then we asked, what do you multiply x minus 4 by to get that? The answer is x plus 2. So x plus 2 times whatever the top was before. Good. Abdullah did the first foil for us. Let me go over and ask Naomi now for some help with the second one. Naomi, we need to foil the second one as well, don't we? Okay, so let's put some lines in to help you out with that. That times that times that. This times this times this. Go. So plus x squared. X plus 1. Say it again. Just x. So plus x, yeah. Plus 2x. No. 2 times 1. Just 2. The bottom is still going to be x plus 2 and x minus 4. Do not FOIL the denominator. There's a good reason to keep it as it is. Sometimes you can reduce it more if there's a common factor after you've done this. But let's collect our like terms now. Let's do that. So I need some help with that. Wanya, that's where you come in. Wanya, can you help me out, please? Can you put all your like terms together? Okay. There's an x squared here, but there's another one here, right? 2x squared. Good. Keep going. 6 plus 3. Okay. Minus 5x, you said? I'm doing this in my head. I'm not getting that. But I could be wrong. I'm not saying I'm necessary. What's that? Minus 3x, yeah. I agree with that. Plus 10. And all of that is over x plus 2, x minus 4. Now, what if we can factor this some more? I'm going to just think for a second. That's 20. Numbers that multiply to give you 20 would be like 5 and 4, 10 and 1. Not 5 and 4, sorry, 5 and 2. What am I saying? That's 20, sorry, 20. So 5 and 4, 10 and 2. None of those is going to give you minus 3. No, we can't factor it again. Okay. So the only thing we have left to do now, if you could factor this again and then maybe there's a common factor, then you would do that. But there's nothing, I can't see anything to factor that. Just thinking off the top of my head right now. Restrictions. Yes.
X can't be negative 2 and x can't be 4.
2 thumbs up on that. X cannot be negative 2 or 4. Those are your restrictions right there. Yes. Can't hear you. I don't think there's anything else we can do with that. Unless you could factor the top, then there is a common factor between the two of them. But I did a quick mental check. I mean, I could be wrong. I couldn't see any way to factor 2x squared minus 3x plus 10. I can't think of a way to do that. Can you? Don't forget, the 2 is in the front. That's the thing. Yeah, so the two numbers that you have, you need to, it's 2 times 10, which is 20, and you have to find two numbers that which will add up to give you minus 3. I couldn't think of one. Top of my head, though, so if you can think of two numbers that will add up to give you minus 3, multiply to give you 20, then we're good. We can try that, but I can't think of any. Okay? All right, are we doing okay so far? Are we doing okay? Not with the phone. I'm talking about doing okay with the math. We're doing okay so far. Back here, we're doing okay? Yes.
For this instance, it's not like that bad
Mhm.
because you know that it's negative 2 plus 2.
Yeah.
You could also use the zero product law, right? To find out.
To find the restrictions. Yeah, you could do that as well. Yeah, absolutely. Absolutely. Okay. Let's see how much more we have left to go here. Okay, looks like we only have 2 more. Then you can be on the way with your homework. All right, so there's this one that we have to tackle. Let me see what the last one is. Right, that's the okay. Yeah, we got the beast coming up, but let's tackle this one first. All right. Do you have a common denominator? Sana, do you have a common denominator? No. Sorry. Let me make that bigger. Excuse me. Let me make this bigger. Do we start off with a common denominator? What do you say to that? Sorry, can't hear you. We can do better than that this time. We don't have a common denominator. Let's agree on that. We don't have a common denominator yet, do we? No, we don't. Here's what I would do, and I'm going to ask you to help me with this. You had your hand up. Good, good. We're going to do that. Your current denominators, if they can be factored, factor them. Okay? If you can factor what you have as your denominator, because that might actually help you to come up with a better common factor than just multiplying the two factors together. So we're going to do exactly that. All right? We're going to factor, I think that was Che who said that. We're going to factor those two denominators right now. So I need some help with that. Um, let's see. Sarah, are you able to factor the first denominator for us, please? The 2x plus 4. What would the common factor be there? It'd be what, sorry? It'd be 2. And what's left when you factor that out? That'd be x plus 2, you said? Yep. Minus. I need some help again. Um, maybe if. Okay, Shreyash, go ahead. And then on top, we still have the 5, right? So all we've done between Sarah and Shreyash is just factor the two denominators. Do you now notice that the denominators themselves have a common factor? And then, of course, there's the 2 and the 3 as well. So here's what we're going to do. Yes, go ahead. Sorry, say it again. X plus 2 cancel out? No, you can't do that. Because first of all, there are two denominators. So you can't just cancel out two denominators. You can't do that. So what does the common denominator look like? Well, let me start by looking at the numbers that are the coefficients there. What between 3 and 2, those two coefficients, would be a common factor? Okay, Angeli, what do you want to tell us? Nice. In fact, that's what the common factor is between 2 and 3. It is 6. Now, this x plus 2 appears both times. And I've kind of said that if something appears more than once, you look for the one with the higher exponent. Well, the truth is that both exponents are just 1. So the higher of 1 and 1 is just 1. Okay? So you're still going to put that x plus 2 as part of your common factor to the power of 1, which means you don't actually put an exponent there. Yes? It's hard to hear with the math. Say that again. Write it down. Okay. Because I had a coefficient of 2 and a coefficient of 3. There's a number here and a number here. We have to try to find a number which both of them can divide in 2. The smallest possible number. That's 6. Now, could you have used 12 or 24? Or, yeah, you can use all those numbers, but those are really big numbers. It's best to use the smallest number, which is simply just 2 times 3, which is 6. Okay? Thanks for the question, Jahim. Okay, so watch what happens now. What do I multiply this denominator by? Let's ask Nakib this question. What do I multiply this denominator by, the 2 into x plus 2, to get that denominator down there? 3. So multiply the top by 3. 3 times 7 minus. What do I multiply? Susan, this one is for you. What do I multiply the 3x plus 2 by to get the 6x plus 2? 2. So it's minus 2 times 5. So what I'm going to end up with is this. 21 minus 10 over 6 into x plus 2, which means I'm going to have on top here 11 over 6 into x plus 2. And that's the end of the road. That's it. That's all. That's done. Except for the restrictions. Except for the restrictions. Okay. Let me hear what you got, restrictions wise. Negative 2 and 4, you said? Good. No, he's okay. So Sachir is absolutely bang on. It's just one restriction. X is not equal to minus 2. That's the only thing that's going to cause a problem. Yes, Gary. Regular 2.
Oh,
No, no, yeah. That would just give you a number, like 10 or whatever it is. I think 12 or whatever it is. Okay, so we have one more. Yes. All right, go ahead. We have one more. Yeah, just one more left. Okay. Remember what we did the last time? We said that if we could factor a denominator, we should. Well, look at that. I'm thinking that these denominators can be factored. Absolutely can be factored. So help me out with that now, please. I need some help with factoring these denominators. Let's see, who haven't I pounced on yet today? I'm trying to think here, trying to figure out. No, I think we've got everybody. Okay, go ahead, please. Mm-hmm. So x minus 4, x minus 3, I agree with you. So 5x on top. And Shaluja is saying x subtract 4 and x minus 3. Minus. How about the second one? Manayo, go. Difference of squares. You seem to spot them very quickly. X plus 3, x minus 3. Okay, so the top is still the same. All we've done is factor the bottom. That's all we've done. That's all we've done. Here comes a vexing question now. That's the thing that we need to figure out. Who has a guess on that? I want to take some guesses on that. First denominator, second denominator. What's the common denominator? Anybody? I'll give you a hint. The denominator is going to have three factors in it. Go. Che. Yeah. Look at you. He's right. He's absolutely right. Is there any other x minus 4 anywhere? No, we have to include it then in our common denominator. Is there any other x minus 3 there? Yes. Do we include it both times? No, we only include it once. So that's going to be x minus 3. It's like to the power of 1, but it's still x minus 3. But we also have to include the x plus 3 as well. Any factor that we had before must be included in the common denominator. So I have to put the x minus 4. I have to put the x minus 3 at least once, even though it appears twice. And I have to put the x plus 3 as well. So all three of those, just like you said, Che, are your common denominator. When you're finished the first part of the test, let me know. You have to submit it, and then I'll give you the second part. Okay? Okay, not rushing. I'm just telling you. Okay, so let's go through the process now. Let's go through the process now. What do I multiply? And I'll take a volunteer on this. What do I multiply this by that gives me all of that? Yes. X plus 3. So we have to multiply x plus 3 times that 5x. Minus, because that's a minus. What do I multiply the x plus 3, x minus 3 by to give me all of this? Yes. The x minus 4. So I have to multiply the x minus 2, x plus 2, sorry, times the x minus 4. That's what we have to do. We're coming up to the end, so I have 5 minutes to go before they start calling us down. But let's see if we can tidy this up very quickly. All right, don't take the phone out yet. Not ready for that yet. All right? So I'm going to multiply the 5x into this bracket. So it's going to be, I'm going to sort of pick up the pace a little bit here. This times that, that times that. So that's going to be 5x squared plus 15x. Now, I need to minus everything that comes out of this. So I'm going to open a bracket, and I'm going to go ahead and start foiling this out. So x times x is x squared. X times minus 4 is minus 4x. 2 times x is plus 2x. And 2 times minus 4 is minus 8. And all of this is over the denominator of x minus 4, x minus 3, x plus 3. You see everything inside this bracket? Everything inside this bracket has to change sign. I'm minusing all of these things, like we talked about before. So I'm going to have here the 5x squared plus the 15x minus x squared plus 4x minus 2x plus 8. Notice that everything inside the bracket, everything I had inside of this bracket that had a minus in front, everything changed sign. This was minus, this has become plus, this has become minus, that becomes plus. And over the denominator of x minus 4, x minus 3, x plus 3. So we have one more thing we have to do. What is that again now? What is that last? Well, two more things actually. Yes, Triash. Collector like term. So we'll do that. So that's 5x squared minus x squared, which is 4x squared. So that's 15x plus, okay, that's 19. If I make a mistake, please somebody correct me. So that's 19 minus 17 plus 17x. And then, what is that? Is that right? 15 plus 4 is 19. Okay. And then, but then the plus 8. I don't think the top of this can be factored. 4 8 is 32. Top of my head, I can't think of any to factor it, so let's just leave it there. The last thing is to give me the restrictions. I'll get it. I'll get it. The last thing is to get those important restrictions. You're welcome. All right. Is it only Che who has all the answers here today? Yes? Athuzan, what do you have? No, forget the bathroom right now. All right. I need some answers from you. All right. Talk about bathroom. Give me some answers. Aaron. X cannot be equal to 4. Yeah. What else? Just negative 3. So plus and minus 3. He got it wrong? Like I said, there's supposed to, well, you didn't give me a chance. Like I said, you need to put it's not equal to. I'm just kidding. I'm just kidding. That is not equal to 4 and the plus and the minus 3. All right.